Hi, morning all. The Q building is a significant investment from the University of Newcastle, one that was co-funded from the state government as part of the Hunter Innovation Project. It's also significant because it's the first project on our Honeysuckle City campus development. So a real challenge, but also a great opportunity that we've had to kick it off here. When we make decisions, sorry, it's come through now. When we make decisions and major investments, we look at how these opportunities can deliver on our strategic plan. So looking ahead, 2020 to 2025 is our current strategic plan. And you can see the emphasis that we have in our values, which wrap around in that circle of excellence, equity, engagement, sustainability. Now, we really focused on this investment to provide benefits around sustainability. So looking at committing and embedding to the UN Sustainable Development Goals as part of our commitments. We have a particular focus on energy and carbon use and waste and recycling. And we've committed to all new building projects to achieve a 6-star Green Star accreditation. In regards to excellence, we look at how do we pursue the exceptional and strive for the innovation through our teaching, research and our operating environments. So importantly, our operating environment here. One of the key priorities in our strategic plan is reimagining our campuses, and with such a significant development within the Honeysuckle precinct, this job was really important to cast an example of the leadership around sustainable resource management that the university wanted to show through our built form. So we're working towards implementing initiatives that work towards carbon neutrality, zero waste and leading water recycling strategies. Through our research, education and campus management strategies, we'll also lead the regions to a more sustainable future. Taking this brief and our commitments in regards to our strategic plan, we looked at this to be an innovating, enabling piece of infrastructure, providing a strong contribution to transition and propel our regional economy. It's also important back when this brief was written that we had that commitment to a 5-star Green Star rating, but we wanted to stretch. So we put in an aspirational 6-star Green Star rating, which became an important element in the project delivery. The design principles that we highlighted here through a design competition actually was sustainability, demonstrate a high degree of innovation and sustainability within the built form, and where possible, trial the unexpected. We also wanted to showcase the sustainability features in the built form. We wanted this project to be emblematic. It needed to represent the university in the city with our growing presence. And also we wanted it to be transparent. It's really important for us, the university, as we increase our presence in the city of Newcastle, to really on show and to integrate in with the community, with also local businesses. So at this time, this is where we handed over and gave the challenge to our architectural team.
Thanks, Damien, and thanks for what's turned out to be a really inspirational brief that has driven the design of this project. From the outset, we looked at sustainability fairly intensively, and that started with coming up with a very robust but flexible floor plan that was able to not only attend to the brief or respond to the brief as it stands now, but also to the various iterations in the future that we know buildings undertake. We located a core in the corner, and then we started to test the array of spaces that were within the brief. But there are also spaces that are very common to other tertiary education building briefs. So they enabled us to test this floor plate, as I said, not only for the current brief, but also into the future. And those spaces, ranged from small office spaces all the way through to larger exhibition spaces. We took that thinking through to the section of the building, and as you can see, looked to provide some higher than normal floor-to-floor dimensions so that we could arrange spaces on various levels. So you weren't only cementing the larger, higher spaces to one particular floor level, you could actually move them through the strata of the building. And then we wrapped that mass timber structure in a very transparent but highly performing glazed facade given the various orientations. And that high floor to floor that we established early on really gave us the ability to reflect the waterfront warehouse vernacular that's within the precinct, particularly in the early establishment of the waterfront precinct, and also the expression of the timber also reflected the infrastructure. The use of mass timber very much led the way in us achieving the aspirational Green Star brief through its ability to sequester carbon. As Damien pointed out, that's definitely one of the targets that the university is looking to, is reducing the carbon. And we really wanted to express that from the moment that you enter the building, so that as soon as you come into the foyer, what's first and foremost in front of you is that use of mass timber. The ability of wrapping the timber frame in glass really gave us that opportunity for the university to reflect their commitment through the ability to see what's happening within the building with the structure from a distance. And then having that ability to then showcase the actual activities that are happening within by the creators and the innovators that accommodate that building. The expression of the exposed mass timber structure played an important role in us also looking at other factors, such as the wellness of occupants. It's found through research that being surrounded by products from nature actually de-stress the occupants within the building. But the use of timber also tested us. It had various challenges, and some of those challenges were around some of the more conventional, looking for alternatives to conventional solutions to some of the specialised spaces, such as television studio, which needs a very flat, smooth floor finish, which is often achieved through liquid membranes, but we were forced to look at alternatives such as a very smooth tiled finish. Some of the other challenges which we're also aware of in the industry is timber's response to fire and water. And what we looked to do with this particular project was de-risk it by locating a lot of those items that have an impact on fire and water in a concrete core, and locate that concrete core in the corner and make that core work really, really hard. So I don't know whether you picked up in the section, but the high floor to floor enabled us to stack some of the amenities within that core. But that core really did help us with dealing with rises as you move through the building and fire rating of those rises, but also the, making sure that our egress was encased in non-combustible materials and on the perimeter. The use of timber, one of the other challenges was the fact that it's prefabrication, so it very much accelerates the letting schedule that occurs up front with D&C delivery, and it's pretty much all hands on deck from day one. And one of the architectural challenges for us is when you look to express the structure, you're also faced with expressing all of the exposed services that come with it. And as we pointed out right at the beginning, the brief had a vast array of spaces which needed a vast array of solutions. So it wasn't as if one solution would fit all in terms of exposed air conditioning and AV and electrical and data and all of the varying services that go into actually making those spaces work. So we very much embrace the chaos, if you like. What I'll do is I'll hand over to Ali to take you through the structure.
Hi, everyone. I'm just trying to share my screen. Good. Hope everyone can see this. I noticed there are lots of audiences across Australia. For the one that they are in lockdown, hopefully you are not that bored and ready for some exciting structural challenges for this project. Before we go to this project, just give you a bit of brief how our journey started in timber. We started in 2015 working on International House, which was the first project in commercial project in Sydney. We did a Carlton Connect initiative, the first timber project in Melbourne, the office building that they had 2 levels of the childcare, which sand pit and all those green area on the top levels. We are doing the first educational timber composite building for Oak Hill College. We're doing also a station development, is a massive in Melbourne CBD South, and also a very nice stands in Granville Stadium, we just finished. Through this journey, there are many people at NORTHROP help me out. The main 2 people that I'm going to focus on today, that the main credit goes to them, is Matthew Burke and Hayden Davis. I'm just taking the credit at the moment, but they have done all the works for this honeysuckle job. So let's start with this one. Very exciting projects, the first of its kind in Newcastle. 4 floors of timber with concrete core. Ground floor slab was suspended slabs on the screw poles, and the core was combination of concrete and precast. The grid is 8.85 by 5.9 grids. I will explain how 5.9 will help with timber and CLT. We had, like many other office buildings, it's a frame building. So we have a glue lam column and beams. The columns was 480 by 480. Above level 3, we changed it to 400 by 400. The beam was matched in terms of width with the column, 480 by 800, and above level 3 was 400 by 800. CLT slabs, 220, spanning 5.9 meter one way. And also this the wall, we had a few walls on ground floor and mezzanine level, which is 160 thick CLT wall. The panels, we had different widths. You might be able to see it in this photo that it was around like 1.25, and some areas we selected 2.25 because of the requirement for the roof, and the length is 11.9. When I was talking about the grid line, normally the container is 12 meter, as you know, and it is very hard to put 12 meter panel in it. So that's 6x9 grid that many people will talk about. If you allow for 6 meter grid, you never could get 12 meter panel to come if it ships from overseas. You always need to shave a bit from either side of it, unless you go and spend more money on the container and go for bigger container that is costly. And the width of it is because of the manufacturer. Different manufacturer has different panel width. In the holes for this specific manufacturer, they have their regular one is 1.25, but they had 2.25 as well. The other structural system, as I mentioned to you, the core was concrete, which created lateral stability. The ground floor slab was suspended on micro screw poles. And the plant room, which is above the roof, is bond deck slabs. So it is steel and bond deck. CLT stairs spanning from ground floor to mezzanine level, as you can see in this photo. And also from there onward, we have CLT stairs, but we put some steel stringer. It was a both requirement from a structural and architectural. Design challenges, like many other timber building. I know that you already been into many of these type of seminars. The codes and design approach is one of the main things. Fire is definitely very important aspects of timber building. Service reticulation, connection design, vibration, and construction loading, which I'm going to touch base quickly on them. Our best friend at the beginning of any of these type of job is our certifier, which we need to discuss and help them and explain to them that why we're using European code instead of Australian code. And it makes sense to us as a structural engineer when you use European species to use European code, as well as, unfortunately, our code is not comprehensive about CLT. And hopefully we could work more on it to include that. And we have a pretty comprehensive Australian code in near future. But when you start explaining these two, it's not a hard sell. It's easy sell to discuss this with certifier if you know what you're doing and why you're using non-Australian code and how you're going around this. Fire is the other one. Again, you've seen many of those type of slides. As you know, the fire ratings, as a structural engineer, you receive the fire engineers gives you fire rating for the buildings, and you go from the charring rate. As you know, the CLT and wall, like CLT slabs versus CLT wall, has different charring rate because of the delamination. Different manufacturer has different type of charring rates. Some of them, they give you the average, but the reality, for the CLT, there is no average. So you start with a slower charring rate, you get to the glue part, or the heat get to the glue part, delaminate, the charring rate would increase, as you can see on the right-hand side here. But you could, some of the manufacturer, they average it out and give you a number here. For this specific project, we did both. Our charring rate was 0.9 millimeter for CLT as an average, but we did both option as well. But this is coming from tests that the manufacturer given us. For glulam is easy, consistent rate. It is specified in the code, and everyone knows about that char rate for the glulam, which is easy to go around that. The other one is panelization. As you know, like for this specific job, as you can see, the core was eccentric core. So we assume the whole lateral loads comes to this core. How this has happened, we need to have a proper diaphragm. So the loads need to come to the core, but because these are all individual panel, so you need to somehow stitch it together. So we put this 3D model analysis as well as doing hand calculation to see how the diaphragm works, finding the stresses in each panel, and then design each of those connections. The connection that is important here is the connection, the stitch plate between the each individual CLT panels, as well as the connection of the CLT and the beam to the core, because that's, as you can see, we used two different connection, an angle on the top and also a piece of glulam on the bottom to basically transfer this load to the core. This is very, very important for any jobs that you do, especially if you have eccentric core on the job. The other challenge is vibration. As you know, like the timber building is susceptible for vibration and acoustic. I'm not expert in acoustic, but as far as I know, it's been used some access flow with eggshell kind of like panel underneath to resolve the vibration of this. But for, the acoustic. For vibration, two things is important. One is damping, the other thing is mass. So whether you have two options, the mass and the stiffness, whether you increase the damping or whether you increase the mass or stiffness. So increasing the damping, it's possible by access flow, the easiest way. There are other ways to increase the damping. And increasing the mass, you could add topping screed. We didn't use this here. We just used this slabs, but because our spans was 5.9, it was pretty good. And thickness of slabs normally will be governed by these vibrations. I think that's why we go for 220 mil timber CLT slabs to control the vibration. A service reticulation, that's a very interesting part. We always have challenge with our friends in building services and then with services subcontractor. It's a key to know that for CLT, whether it's wall and slabs, it's much easier to do the vibration, to do the penetration in it. You could have a fire collar that has been tested for CLT slabs and wall, but for the beams it's not that easy. For the beam, as you know, whatever penetration you would put in your beams, then you expose in four sides. Inside that penetration, the char rate is not just from the side and the bottom and top of the beams, but also through that penetration. That's why there are different ways to control those size of the penetrations that I assume everyone knows, going through the German annex and Eurocodes to do that. And we did that. But the main key is starting very, very quickly early on to work. For these projects, we were fortunate to work with EJE and Hansen Janken from day one to understand how the services is going. And it was a very smooth procedure by doing clash detection through BIM 360 and also minimizing the amount of penetration into the beams, because we had pretty good head height and the exposure of the services that EJE wanted helped a lot to reduce this, which makes it very, very good solution and cost-effective solution at the end. But for the one that we have to put the penetration, we checked it, designed it, and strengthened it when it was required. The connection, it's another interesting and challenging part of this timber jobs is most of you are familiar with Megan connection we use for the columns and beams, Megan connection that is clicked with each other. I spoke about the diaphragm connection. As you can see, there was a rotoblast stitch plate on the slabs, and also we have half lap length self-tapping dowels. The main one that is, I think, is important for any structural engineer to know is connection of timber to concrete or steel. Because connection of timber to timber is easy because it is CNC machine, everything is inch perfect. But you have the concrete, you have the side tolerance for the concrete. That's why your connection should be flexible enough, but at the same time robust enough to transfer the load, flexible enough to support these tolerances, which we've done and come up with a idea of like a plate connection to the core, work with Hansen Janken through that and successfully done that. As you can see, this is one of those timber to concrete connection. And this is a nice photo. This is normally a headache for any structural engineer. When our builder friends comes in, you start the work and said, oh, Ali, by the way, we want to put this much of a storage here. We want to use this scissor lift, blah, blah, blah. We work well with Hansen Janken on this job. As you can see, there are a number of different things that you need to consider. This is not just for your normal 3 kPa loading you put on the floor. You had some bigger concentrated loads, which we help with the builder, with Hansen Janken, to see which area you could put a storage. You could go more than 3 kPa, which area you should stay with 3 kPa. If you have movable loads, how you go around it. But this is another important aspects of this timber building design when you come to construction loading. And the last things is a few other items. Some of them, it wasn't valid for this job, but for this specific building or any other timber building, staging and lay down area is very important, like tagging up, because it's important which part of timber you go first, is all those tagging, how you put it laid down in order to be able to use that fast speed of construction. If you don't do it, then you could not utilize that fast speed. Site welding is important when you're doing it. If the timber is on there, try to avoid it. Moisture sensor for underneath of the slabs. When you have a bathroom or kitchens or planters, you could use them to check and the moisture if possible. Supply chain is another important thing, especially if you take things from overseas. Jono could talk more about this, but it's important about the timing. And at the end is the facade access. We didn't need for these jobs, for other jobs that we've done. I think the structural engineer need to know about how to connect it. If it's a davit arm system or if it's a unit system, how you control the roof to put those davit arm, etc. Do you need to put concrete or not? But for this building was easy because they're using the access from outside for facade. That's all structural. Now I am giving this to Jono.
Okay, thanks, Ali. Good morning, everyone. I'm Jono, the project manager from Hansen Janken. I just wanted to start with a couple of thank yous, I suppose. Just that mention that it was a really enjoyable project to be a part of. Something really different, and yeah, a lot of research and investigation as we come into the project. But yeah, really enjoyed delivering our
probably what was our 20th project for the university, Damien, something like that. Great relationship ongoing with APP as the client-side PM, and thoroughly enjoyed working with EG and NORTHROP, the teams that we work with closely in delivering the project. Just want to provide a bit of insight, I guess, from a builder's perspective. Looking at the DNC design inputs, I suppose this is, from my perspective, where I think we added value to the design process as part of our DNC obligations. And then also just talking about the fun of the build. As I said, it was a really enjoyable project to be a part of. So just talking about some of that specifically. So a couple of key details from in terms of our engagement on the project. So I guess there is a bit of talk in the industry about early contractor involvement with regards to mass timber projects, and I understand there are significant advantages to it. But for us, the project ran really well under a traditional DNC contract. For us, it was a GC21 contract, similar to the previous contracts that we've delivered projects under for the university. When we came onto the project, how would you describe it, Ant? I guess it was, you know, around that 70% plus in terms of design. Spatially, the building was all locked down. That sort of consultation process with the university had all been resolved. But the structural design was sort of a little bit behind that, and particularly in regards to the mass timber, there was still quite a bit of work for us to do in that detailed design, particularly working through the consultation and coordination with services design. So we brought NORTHROP in as part of our team and really enjoyed that process, working together with EG and our services consultants and other consultants along the way, finalising that detailed design, working closely with the fire engineer and the certifier, as our lead touched on, finalising that detailed design in just 12 weeks. We then moved into shop drawing and fabrication phases, which during that process, we were working closely with our manufacturer, Binderholz, and also with our installer, Savcon, which provided a lot of benefit, both in the installation, as we'll see a bit later on, but also in being able to rapidly progress the shop drawing and fabrication model in just a few weeks, which is what we needed to do because we needed mass timber on site within 17 weeks of starting on site. So pretty rapid procurement, but something that was, I won't say it was easy, but it was manageable under a DNC contract. And you'll see the benefit of that. I'll show you in a short video at the end of my presentation here, is that we were able to install all of the mass timber elements within 29 working days across what is approximately a 600 square metre floor plate across 4 levels. So I don't want to cover too much ground that Ali's already covered in terms of fire engineering, but I guess what we were able to bring to the table was knowledge of subcontractors and suppliers availabilities in terms of service penetrations, working closely with NORTHROP on the connection details, which they had some great initiatives in that regard, and also looking at slab edge details, and we needed to incorporate an intumescent cavity barrier where we had some FC cladding on the facade, where we didn't have the electrochromatic glazing curtain wall. So in terms of service penetrations, there are quite a few options, but I would say that in Australia, it's still fairly limited in terms of what's available that is certified tested systems for CLT penetration. So this is a photo not from our project. We do have some penetration similar to this on the project, but this is from a ProMat website. Also, Hilti has some good products. TBA Fire's got some tested systems, and I'm sure there's others that I haven't mentioned as well. But in terms of what we're doing in Australia, it is relatively limited with what is readily available, certainly in the European marketplace. And obviously just that has a massive impact for us in terms of the build. And that's why, you know, we're so keen to be involved in those discussions, because it does make a huge difference to how efficient you can be during the installation. You can see there that the large beam laying on the ground, that's now the Savcon guys and our crane crew installing that beam there. That connection detail, particularly back to the core, worked really well in terms of efficiency. So yeah, just touching on that same idea, the buildability inputs that we were able to provide in that design stage, involving both supplier and installer in the process, looking at the installation sequence, looking at the connection details and making some simple modifications to those to make them more efficient, and also looking at the lifting points and making some minor adjustments to those with what we knew would be needed for the requirements in Australia. So Ali talked about panelisation. A good example of that, yes, we've got a 1250 wide panel from Binderholz, which is pretty easy to get on and remove the lifting points that you can see in that little photo there. So we used a Schmid T-lift shackle over a Schmid screw, which was one of the issues we had on the project. The shackles themselves went missing in transit. So we had a Schmid screw and we weren't able to get hold of a Schmid shackle. Speaking to the guys in Europe, oh, it doesn't matter, all the supplies are interchangeable. That's not kind of how things work here in Australia. We weren't able to get sign-off or certification on using the two different proprietary products together. So working with Savcon and our crane crew, we came up with an arrangement of soft slinging those panels into position and then a bit of lost time and then ratcheting them into position, which got us out of trouble for the couple of days while waiting for the shackles to turn up. But also just thinking about the propping arrangement, safety and design, we're always trying to have the installation, the installers operating in full restraint as opposed to full arrest, which, as I said, is relatively easy with a 1250 wide panel. But when you start going to a 2.2 wide panel, as Ali mentioned, you can see that wider panel in the image there on the right-hand side. Getting up and safely removing those shackles as part of the installation, we needed some additional controls around that to be able to manage that safely. Ali talked about the modelling coordination. Just the use of BIM 360 and the way we fully coordinate to a high level of detail is something that we do as business as usual at Hanson Youngkin. And it made a massive difference for us in terms of being able to resolve that detailed design efficiently. I've heard of projects where that's either consultant-led or sometimes mechanical contractor-led. We think it's really important that it is builder-led. That's because as the builder, we have, the relationship with all parties that are involved in that process. And, sometimes it's needed, but a contractual relationship where issues need to be managed and resolved, which is really important for efficient resolution. You can see on the photo on the left, we had some pretty significant mechanical penetrations up through the top level, up to the rooftop plant, which needed to be managed through the fire engineering report with an alternative solution. And then in the image on the right, you just see, as Anthony talked about with the exposed surfaces, things needed to be really well coordinated so that they were presentable where we had congested areas like that. And we also had relatively congested plant rooms with quite a bit of mechanical plant in the small plant room, relatively small plant rooms that were available, and structural penetrations and the like as part of that as well. Okay, so just touching on logistics and procurement. Most suppliers, as you know, will ship CIF, which is basically throw it over the bow and someone else's problem to an extent. We had the opportunity to work with a fantastic logistics partner as part of the process. Transways, they did an excellent job in getting that material to site for us. And Ali talked about this previously as well. It does make a huge difference for efficiency and for cost to have a big laydown area. So you can see that's our structure there sitting waiting as the timber arrives, day one. And you can see we've got a nice big laydown area on the left-hand side where we could line up the materials. Working with your supplier, you'll always manage the way that it's going into the containers, the order that it's being provided, but you don't always have it. It's not always possible to fine tune it to be literally lifting every individual panel off the truck straight into the building. And that's something that is quite expensive to manage with a logistics partner and can involve quite a bit of handling of the material and also some warehousing potentially as well, which obviously minimise that and keep the cost down. So something else we do at Hanson Youngkin as business as usual is we use drone deploy to track and manage all our building projects. Just touching on a couple of things that we do with that. It's a point-in-time reference tool and it's a multidisciplinary tool. So just touching on a couple of aspects of that, we use it to capture aerial data, which we can then use for tracking progress and comparison between dates. We use it to manage our in-ground services as built, particularly as we're progressing the works. That's important, and we use overlays for that as well. We also use overlays for our slab set out pre-pour planning and QA checks. We use it for stockpile artificial intelligence, managing and measuring quantities of material. And we use it for capturing point cloud imagery as well. So you can see there point cloud capture of the mass timber being installed, which we use it to confirm the positioning of the mass timber as it was going in. We also use it for managing as-built services installation against design, feeding that back into the model and running coordination sessions. And then we can also use it to measure, you know, the installation internally and confirm coordination and locations. So dealing with aesthetics. So Anthony talked about this earlier on, and I think it was excellent for us coming onto the project that EG and the university had a really clear vision on what they were looking to achieve with the aesthetics of the timber. For us, that incorporated a non-visual grade CLT. So you can see in that image there, there's quite a few marks and some discoloration in the CLT, which was something for us to manage during the installation, but aesthetically did achieve a really good result against the visual grade glulam columns and beams. Other things that impacted on the aesthetic, whenever you've got a structure that you're wanting to effectively use as a finish, there's always issues to overcome. For us, water. I think, you know, the couple of months where we had installation and then putting the curtain wall on, getting the roof on, it's probably the wettest couple of months in the last decade. And there's no real structural or performance issue for the timber in getting wet, but it does have an impact on the aesthetic. The timber yellows pretty quickly as it's being installed, and the moisture does make it look more weathered as well. And I guess that's something that we probably hadn't anticipated the full extent of, is the surface preparation that is required in bringing that timber up to an acceptable level of finish, which needs to be readily understood by the team prior to engaging in that process, which it was for us here, which was great. But definitely a lot of work in that surface preparation. You can see there the push-pull plates that we've got fitted to the columns. When they come off, there'll be a white patch where the timber hasn't yellowed because it hasn't been exposed to the sun. We also had some drill and plug or drill and dowel connections, which when those dowels are sanded off, that will leave a light patch which needs to then be transitioned through the column and beam arrangement. But yeah, certainly a lot of work in preparing the finished product when you're exposing as much of the timber as we have on this building. And that photo there just sort of shows how quickly the timber will change colour when it's delivered to site. So you can see the top level up there at level 3 has just gone in, and the bottom level of ground floor has been in for a couple of weeks, and you can see a clear discoloration that's being developed in the lower levels of the panels and the glulam. Okay, so we also capture 3D walkthroughs using drone deploy. And just to finish, I just wanted to show you a short video which gives you a demonstration of the process and just shows you just how quickly the mass timber installation was completed on the site. So we started the mass timber installation on the 7th of October. So in this video, we're starting about a week into the installation. You can see that we've got all of the level 1 columns and beams, the glulam installed, and we're working through the installation of the CLT panels. We knew that the first floor would be a little bit slower. We didn't pre-fit the base plates to the timber columns. That was fit here in Australia as part of that installation on site. We did that to speed up the time to shipping for the timber. And you can see that we've also installed the mezzanine level, which Ali talked about, and we've installed the mass timber stairs there as well on the ground floor. So fast forward a week. So we're 2 weeks now into the mass timber installation, and we've already got that first level complete. You can see that we've got our edge protection on. That area is fully handed over and signed off by Ali's team, and we're up accessing and commencing the installation of the level 2 support structure, the columns and beams. You can see our services penetrations already cut in the timber prior to arrival. And as we come around the corner, you get a good look at that at the core, which we had completed, ready for the arrival of the timber. So you can see we're working into level 2, and we've still got the lift openings up there for level 3 and the roof to go on. So fast forward another week. We've been on site for approximately 3 weeks at this stage with the installation of the mass timber. And you can see that the level 2 deck is complete. So it's signed off. We've moved up there. Our guys and the Savcom guys are working through putting in modifying a couple of the final lap boards and adjusting some of those final connections back to the core. But it's signed off for safe access, and there you can see the core. And so, you know, we're 3 weeks in and we're effectively 50% through the installation, with level 1 and level 2 being complete. And you can just see a small opening there that we left just to drop scissor lifts and other pieces of plant for Ali to sign off on for our use during construction. Come forward into November. So just under a month on site with the mass timber. And in that week, we've completed the level 3 in its entirety, just about. So we sort of certainly working with Savcom, we got more efficient as we were going up through the floors. So level 3 complete there with beams and columns installed. You can see those push-pull plates there, which exposed to the sun have an impact on the colour there of the timber. And we also have incorporated some structural steel elements, which were supporting some acoustic walls. So fast forward another week, just over a month of mass timber installation. If we come up to level 3, again, we've completed the roof structure, or level 4. So just a couple of weeks for the last 2 levels. So the glue lam columns and beams have all been installed. You can see that discoloration that I was talking about there on the soffit, because it was a non-visual CLT. So it's, you know, handled and packaged and treated in a different way to what a visual grade would be. So there's a bit of additional work for us in preparing that prior to sealing. And you can also see the mechanical penetrations that we talked about before up to the rooftop plant deck, which needed to be managed with an alternative solution. We've got a couple of examples of what I was talking about there. So then we go forward 1 more week to the middle of November, and the installation is fully complete. We're up on the roof. We've got some temporary waterproofing going down, and we've already landed our prefabricated structural steel, which makes up the base of the rooftop plant deck. So that was it from me. Yeah, really enjoyable project to be a part of, as I said. And yeah, it was great working through the detailed design with the consultant team, and the installation ran extremely well also.
It was fantastic, everyone. Like an amazing project. I love that drone walkthrough you've got there, Jono. You can go and have a look at the drone deploy. Actually, I might just start with a question for you, Jono, before we jump into the questions from the audience, and I encourage people to put them in the question and answer box down below. But you mentioned the concern about water in particular, and also the sun coming in and fading the CLT. Did you guys contemplate doing the facade progressively as you were building the building? Would that have been a benefit for you to run that up to give a bit of that protection from that point of view and to reduce your building overall period?
We definitely did have a look at and discuss some of that. Structurally, we really needed the bulk of it completed to be able to support that facade hanging off the building.
Okay. So we've got a whole range of questions here, which is great. So one which I'll probably pitch to Anthony just around the acoustic design. There's a question there around, did the floors have a concrete topping? I assume that was from an acoustic point of view.
The way we dealt with acoustics floor to floor was we put in a computer floor that sat on top of the CLT slabs on each level. And then had acoustic bats within that subfloor. And then around the facade, we had some flanking insulation, acoustic insulation and barrier to stop the flanking that often occurs from floor to floor via the facade. But, you know, with all challenges like that, you get opportunity. So the fact that we had the false floor to manage the acoustics also gave us the opportunity to run riot with servicing through the floor for power and data in particular, and reduce the amount of exposed power and data in the ceiling.
Fantastic. Now, we've got a couple of questions here from, I'm sure, the engineers just around the core, which is always is of interest. So one there, how did you account for the differential settlement between the CLT components and the concrete core? Assuming the concrete's not going anywhere and the CLT is likely to get a little bit of movement in it.
Yeah, normally this differential settlement is a problem when you have pretty big high-rise building. For this 4-story, the difference is pretty minimal. So which is within your normal allowance for any differential movement. But if you go like 20-story building, then you need to overcome it with some sort of like a steel connections to reduce that differential settlement. Yeah. And
a question here around the positioning of the core being in the one corner, particularly around earthquake design. How did you satisfy those eccentricity requirements for earthquake design with the core?
Normally our code is asking for accidental eccentricity, which is 10% of the width plus the normal eccentricity of the geometry. When we designed the whole building, because I've seen someone ask about the software we use for lateral stability, we use ETABS, and our smart colleagues, Travis and Richard Officer from Newcastle office model these. But basically it's just two things is important. One is checking the diaphragm is working for that eccentricity, as well as the displacement at each level, which we satisfied. The footprint is not huge. If it was a big footprint, you possibly needed shear wall or bracing the other side. But with this one, we were able to manage that torsion.
Thanks, Ali. Look, there's a question here around the softwood packaging used for modelling, which is quite an interesting one. So that might be something that Ali, Anthony and Jonathan all want to speak in, because I do note you were talking about the use of BIM 360. So maybe each of you might like to talk about the software you use, and was that integrated through some sort of BIM model to try and sort of, help with the process?
Yeah, so from the outset during the design phase, even before we got to procurement, we were developing a model in Revit with the full understanding that that model would be transferred over to the successful contractor as being a part of the delivery tool. So we were very conscious of that up front.
Similar to us, we use Revit. We always use Revit for our buildings. This is no different to that. Yep.
And then for us, when we get involved, we basically coordinate that in the BIM 360 space. So, all the consultants, the subcontractor designers are all uploading their own IFC files once a week into that coordination space within BIM 360.
Mm-hmm. And Anthony, was the BIM model important from the client's point of view? Often that's the case with BIM, that they want to be using this sort of after the building's completed for sort of ongoing maintenance over the life of the building. Is that a key part of the BIM investment?
Yeah, in the services RFT, there was a requirement for us to produce some form of BIM model for the university to take over at the end. It all comes, the level that you go to, quite often some clients are very aspirational in the level of detail that they want the BIM model to be in at the end of handover. But what we've learnt with, continuing the conversation with the client through the development of the model with their operational staff is sort of tailoring the BIM modelling that we do hand over to the client with what they want to use it for. Because sometimes you can be over aspirational and end up with a very large clunky model that no one's really using the level of detail that's in there. The university is a very educated client, particularly around their ops staff, in understanding what level of information they want. So it helped us to reduce and pare it back and not overload it.
Fantastic. There's a question, two questions here which sort of interrelate with one another. They've just jumped down the screen now as people have added them in. But the first was about what was the cost of the project per square metre of floor area, which we often hear asked. And you guys might like to speak about this, but reality is it's not really about the cost per square metre. It's about the cost saving in terms of the completion of the building. And that's linked to another question about what would you say in the time saving as a percentage compared to other traditional construction methods for a similar building. So I'm not sure whether Jonathan or Anthony...
Yeah, I can talk to that while we're just crunching some numbers behind the screen here. I can talk to the efficiency in time. So there's no doubt, you know, when I was presenting that installation process, you know, installing 4 levels of structure like that using traditional methods would be a lot slower. I guess the factor for us on this project was that because we had a concrete core, yes, there was a saving in terms of the installation of the structure, and maybe that reduces the resources that we need to provide to the project to an extent. But ultimately, we were established on site earlier than just the mass timber, obviously, with the completion of that concrete core. So overall, yes, there may have been a slight reduction in the overall program using the mass timber, but for us, incorporating that precast and in situ concrete core in advance, the improvement on that was not significant, and the overall cost of the build per square metre is between $6,000 and $7,000 a square metre.
So, John, just following on from what you said there, does that mean you would reconsider on another building going with a mass timber type core rather than almost like building the concrete building and then coming in with timber afterwards to get that benefit of speed on site?
It's an interesting question. It might be a better question for Damien, to be honest. It's more about what is the client comfortable managing in terms of risk. Like Anthony talked about, the reasons that core was there was about keeping the wet surfaces away from the timber, providing a 2-hour rated concrete fire stair. If you move to an all timber building, yes, you'll get some efficiency in time, but you move away from some of those, or I guess you're accentuating some of those issues within your occupied building, potentially. Do you want to comment on that? No, Damien's nodding.
There's a question just here.
On that.
Yeah, I was just going to flow on from what Jono said from a design perspective. You know, we were presenting to the university a fairly adventurous design in the use of mass timber structures. So the use of the concrete core was for us as much as the client, but it was driven by us as being a de-risking a lot of issues that we saw pertaining to the potential use of timber. Having delivered in timber before, I think we may have a more less risk averse attitude to the use of a timber core versus a concrete core.
Next job, Anthony, next job.
And look, there was a question here around the width of the CLT panels, which I did wonder myself. Just what was the rationale behind using 1.25 metre wide panels as opposed to say wider panels? Was it easier for construction or cheaper? And do you think it would have been quicker or easier to install less panels if they were wider?
Like, I think I can answer to this, or Jono can answer to that. Like, basically it was because of the manufacturer. They have 1.25 more readily available, and I would have assumed also it was more cost effective for them. As a structural engineer and a builder, I think both of us would prefer 2.25 or 2.5 or whatever is much easier.
Yeah, that's right. It's really just a cost decision in the fabrication, and the knock-on effect of the installation cost isn't as significant as the reduction in production saving.
Yeah. And there's been a couple of questions here just on supply of the CLT and glulam coming from overseas. I guess in terms of a carbon point of view, it would be, you know, probably more effective to be using something from Australia. Well, what was the situation about local supply versus overseas supply?
Yeah, so there, in terms of what's available in Australia, when we were procuring this project, the structural requirements for the glulam, no manufacturer in Australia was able to supply the depth of and width of beams and columns that we required for this project. Certainly the CLT panels could have been supplied locally, but that had probably the potential to impact on the aesthetic, where you would have a spruce sitting up against a pine, which probably not desirable.
Okay, well, look, we're just about out of time, so I'd like to thank all the speakers today. It's been fantastic, a really exciting project, and you did a terrific job sort of covering all of that. I would remind people online today, if you're interested in mid-rise construction, WoodSolutions has a mid-rise team that can help you out with any of your questions that you might have in terms of your projects. I also remind you that the webinars are recorded, so if you're interested in going back and re-listening to this one or letting your colleagues know about it, just go to the WoodSolutions website and click on the webinar tag over there to access them. Our next webinar is in 2 weeks' time on Tuesday, the 17th of August. And we've got actually a really exciting and interesting topic here around regenerative design and timber. So a lot of you would know, if you're into sustainability and environmental thinking, regenerative design is sort of the next evolution of where we're going with all this. And we have Associate Professor Philip Bruce from the Live Smart Research Lab at Deakin University talking on this topic. So thank you all once again. Thanks again to the speakers, and thanks for all of you who are attending today. We'll see you again in 2 weeks' time.